Welcome back to the Deep Dive. Yesterday on AI Today, we were really digging into this whole concept of AI hallucinations. And as we talked about, they're not really bugs, are they? It's more fundamental to how these models work. They're always predicting.
Exactly. They're designed to hallucinate, in a way, predicting the next word, the next concept. Ideally, it all lines up with facts.
Ideally.
Yeah.
But sometimes those predictions, well, they go off track. They have these bad trips, as we call them. And that's a huge sticking point, especially, when you're thinking about AI in customer service.
Oh, absolutely. I mean, these large language models, they're incredibly sophisticated pattern matchers, prediction engines. They generate text that sounds right. It sounds plausible.
Right.
But that's not the same as being factually correct. And in customer service, get something wrong, even if it sounds convincing, and bang, customer trust just evaporates.
Which perfectly tees up what we're diving into today. We've got some really interesting material here that tackles this exact issue, these AI bad trips, specifically in customer service settings.
We do. We're going to explore something called attentive reasoning queries. ARQs, for short.
ARQs.
Okay. Yeah, and the idea is they're designed to sort of keep these AI agents from going off the rails, to prevent those hallucinations, or at least the harmful ones.
Okay, a potential game changer then.
Could be. And what's really cool is this isn't just theory. ARQs were developed and tested inside a framework called Parlant. It's open source, focused on real-world use.
Ah, Parlant. Okay.
So our mission for this deep dive is to really get under the hood of ARQs. What's the tech? What does the research say? How could this actually change customer service?
And we'll be looking at a specific research paper, right?
Yep. It's titled Attentive Reasoning Queries, a systematic method for optimizing instruction following in large language models. Quite a mouthful.
Yeah.
And we'll also look at Parlant itself, the GitHub info, the docs, see how it all fits together.
Great. So we know hallucinations are bad. But let's really break down why they're so problematic in customer service. It's more than just like a funny mistake sometimes.
Oh, much more. Imagine you're the customer, right? The AI tells you the wrong product spec, or it misunderstands a return policy, maybe even offers you a discount that doesn't exist.
Oh, yeah. Instantly annoying.
Exactly. It damages your confidence in the company, not just the AI. And the paper explicitly mentions this inaccurate statements, offering things it shouldn't. These are direct results of hallucination.
And there are other issues too, right? Like remembering instructions.
That's another big one the paper points out. LLMs can struggle to hold on to instructions given earlier in a conversation. Their reasoning can drift, gets inconsistent.
It's like talking to someone who keeps forgetting the main point you just made.
Precisely. In customer service, that's a deal breaker. It totally undermines the whole point.
So the usual ways of trying to fix this, like chain of thought prompting, where you ask the AI to explain its thinking, that doesn't quite cut it.
It helps sometimes, but the research suggests it's often not enough, especially for specific domains like customer service. You don't get fine-grained control. It's hard to force the LLM to stick rigidly to these specific rules or this specific knowledge base.
Right, it's still a bit too freeform, so these problems really slow things down and erode trust. Okay, so bring in the ARQs. How do attentive reasoning queries fix this? What's the secret sauce?
Okay, so ARQs take a different path. It's much more structured. Instead of just saying think step by step, ARQs guide the LLM through a predefined sequence of reasoning steps. Using targeted queries. Very specific questions injected at just the right moments in the AI's process. These questions basically force it to revisit critical instructions or perform specific intermediate reasoning checks.
Okay, so let's figure this out in more like a checklist. Have you considered X? What about Y? That kind of thing.
That's a really good analogy, yeah. The paper uses one I like choosing a restaurant.
Yeah.
You don't just randomly pick, right? You probably think, okay, what are the dietary needs? What's the budget? Location. Then you evaluate options against those criteria. Maybe then you think about preferences.
Right. Structured review, then structured evaluation.
Exactly. IRQs try to mimic that structured thought process for the LLM.
So for the restaurant example, instead of recommend Italian, it'd be more like query 1, are there vegetarian options needed? Query 2, what's the desired price range? Query 3, user location is.
Precisely. Very specific targeted questions, and often these IOQs are embedded within predefined JSON schemas.
JSON schemas, like data structures.
Yeah, think of them like blueprints for the reasoning. The schema holds these pinpointed queries designed to make the model focus on the relevant info just when it needs it.
And these queries can be general or super specific to the task.
Both. You can have general-purpose reasoning queries or highly domain-specific ones tailored for, say, insurance claims processing or handling a specific type of tech support issue.
Okay, that makes sense. The JSON provides the structure. The queries provide the guidance. Can we see what that looks like?
Yeah, figure 1 in the paper gives a good visual for the restaurant idea. You'd see fields in the JSON like dietary needs, cuisine preference, location, each potentially paired with a query like, does the user have restrictions, or identify preferred cuisine type.
Okay.
The answers to those then feed into subsequent queries, maybe evaluating specific restaurants against those answers, leading step by step to the final recommendation. The AI isn't just guessing, it's working through this structured Q&A.
It's like providing scaffolding for its thinking. So what are the main steps when ARQs are actually used in a system like Parlant?
The paper breaks it down into a 3-step process, usually. First is the leading ARQ phase.
Leading ARQ phase. Okay.
This is where the LLM processes that sequence of targeted questions. The goal is to, 1, reinstate key instructions, 2, bring back important context, and 3, facilitate that step-by-step reasoning.
Got it. Setting the stage, basically. Step 1, what's next?
Step 2 is response generation. Based on the answers derived during that leading ARQ phase, the LLM then actually generates its response to the user.
Makes sense. And step 3, is there a check?
Yes, an optional but often crucial step, response verification. Here, the LLM kind of checks its own work. It might answer more predefined questions like, does the generated response meet constraint X? Or is the recommended action allowed by guideline Y?
Like a self-critique?
Exactly. If it finds a problem, it can loop back, revise the response, and verify again until it gets it right according to the ARQ checks.
That sounds really robust. But how do you know which queries to put in there? Is it just guesswork?
That's the beauty of it. It's not guesswork. You design the ARQs using your domain knowledge.
Okay.
If you know that your customer service AI often messes up, say, international shipping rules, you build ARQs specifically targeting those rules and decision points. Check destination country. Is item eligible for export? Calculate correct shipping fee based on Table Z.
Gotcha. So you proactively target the known failure points, unlike just general prompting.
Precisely. You're injecting specific expertise into the reasoning flow. And another bonus, this structure makes extracting the final answer much cleaner.
How so?
Often, the final decision or piece of information is simply the answer to one of the last ARQ queries in the sequence. It's not buried in a long, rambling paragraph of chain-of-thought text, much easier for humans or other systems to parse.
That's a practical benefit, for sure. Easier oversight. And you mentioned something about recency. How does that play in?
Right, the recency effect. LLMs tend to pay more attention to information that's near the end of their input context. It's sort of fresher in their attention window.
Okay.
ARQs leverage this by putting those leading ARQ questions, which often restate critical rules or context, right before the final response generation step.
You're putting the important stuff front and center in its mind right when it needs it.
Exactly. Like reviewing your notes just before an exam, it ensures those critical constraints are highly salient at the crucial moment.
Clever. Okay, this sounds really promising conceptually, but does it work in practice? That brings us back to Parlant, right? This is where ARQs were actually built and tested.
That's right. Parlant is the open source framework where ARQs were born out of necessity, really. Trying to build reliable customer service agents forced the development of this technique.
So remind us, what's Parlant's main goal?
Parlant bills itself as an engine for, and I like their phrasing, controlled, compliant, and purposeful generative AI conversations. The key bit is without the unpredictability.
Right. Harnessing the power, taming the chaos.
Pretty much. It aims to let you build powerful customer-facing AI agents, but agents you can actually trust to follow the rules and not make stuff up.
Makes sense for business use. What are the core parts of a Parlant agent?
4 main things, according to the paper and docs. You've got the agent profile, basically who the agent is and what it does.
Okay.
Then behavioral guidelines. These are crucial. Think if-then rules dictating behavior. If customer asks for refund, then follow policy X.
Got it. Rules.
Third, a tool suite. External functions the agent can call, like looking up order status in a database or processing a payment.
Right. Real-world actions.
And finally, a domain lexicon. A glossary of terms specific to the agent's job, jargon, product names, etc.
So identity, rules, tools, and a dictionary. Very structured. What are the absolute must-haves for it to work right? The constraints.
Parlant stresses 4 key constraints. 1, Strict adherence to those behavioral guidelines, no exceptions.
Right.
2, appropriate tool use, knowing when to use a tool and how. 3, accurate use of the profile and lexicon info. And 4, super relevant for us today, eliminate hallucinations and unauthorized actions. Full stop.
No rogue agents. So how does Parlant actually enforce all this when a user sends a message? What's the flow?
It uses a modular pipeline. 3 main stages. First, guideline proposition. The engine figures out which of those if-then guidelines are relevant right now based on the conversation.
Okay, which rules apply?
Exactly. Second, tool calling. Does any active guideline require using a tool? If yes, which one and how?
Makes sense.
Finally, message generation. Taking the active guidelines, any tool results, it constructs the actual reply to the user.
And ARQs are used in all these stages.
Absolutely. They're kind of the engine within the engine modules.
Yeah.
The paper's appendices show how, in guideline proposition, ARQs help score how relevant each guideline is. In tool calling, ARQs guide the decision on if a tool is needed and which parameters to use based on the guidelines.
Right.
And in message generation, ARQs help synthesize the final text, making sure it respects the active guidelines, and, critically, filtering out potential hallucinations before they reach the user.
So ARQs are the mechanism ensuring control throughout the process. I also saw something about self-critique in Parlant.
Yes, that ties into the message generation part. After drafting a response, Parlant can use more ARQ-like steps to make the agent check itself. Does this draft violate guideline A? Is this statement factually supported by the tool output?
That verification step again.
Right. If it finds a flaw, it revises. It's an iterative refinement loop to improve compliance and accuracy before sending the message.
Generate, check, refine. And Parlant really focuses on managing those guidelines in a granular way. Why is that important?
Because it gives you precise control. Each if-then rule is a separate unit. You can track it, update it, see exactly when and why it fired. It makes the agent's behavior much more transparent and maintainable than just throwing a giant wall of text instructions at an LLM.
Yeah, much more auditable, I imagine. So boiling it down, the problem Parlant tackles is building customer service AI that works reliably, doesn't invent things, and follows business rules.
That's the core mission, yes.
Yeah.
Addressing those critical needs for deploying AI in sensitive customer-facing roles.
And it's open source, free to use. That's a big deal. Where is it being used? What kind of industries?
Given the focus on control and compliance, you see it in places where that's non-negotiable. Regulated industries like finance, healthcare communications, legal assistance, also compliance-heavy tasks, brand-sensitive customer service, even things like personal advocacy bots.
Places where getting it wrong has real consequences.
Exactly. And it's flexible, too. Works with models from OpenAI, Google, Meta, Anthropic.
Good to know it's not tied to one vendor. Okay, we understand the problem, the proposed solution with ARQs, and the framework, Parlant. Let's talk results. What did the research actually find? How effective are ARQs?
Right. The paper details experiments comparing ARQs head-to-head against other methods. They looked at those 3 core Parlant modules: guideline proposer, tool caller, message generator.
And they tested ARQs against what?
Against free-form chain of thought, prompting the think step-by-step approach, and a baseline control with no specific reasoning guidance.
Okay, and they used in-context learning for all of them, right? Showing examples in the prompt.
Correct. Carefully chosen examples for each method to make it a fair fight. Same basic prompts, same goals, just different ways of eliciting the reasoning. ARQ examples had the structured queries. Coqui examples had the free-form thinking.
And what data did they test this on?
The pretty decent data set, 87 test cases. Some focused just on guideline accuracy. Others were full end-to-end conversations testing the whole pipeline, designed to be challenging.
Covering different situations. Which AI model did they run this on?
Primarily GPT-4o models from OpenAI, ones they'd found worked well in their practical Parlant deployments.
Okay, moment of truth. How did ARQs stack up?
Pretty darn well, actually. Across all the test cases, the ARQ implementations had the highest success rate, 90.2%.
90.2%. How did the others do?
Chain of thought came in at 86.1%, and the control baseline was lower at 81.5%.
So a clear win for ARQs. A noticeable improvement over both chain of thought and just basic prompting.
Yes, statistically significant improvement.
Were there specific areas where ARQs really shone?
2 areas stood out, according to the paper. One was guideline reapplication, tricky situations where a rule needs to be applied again later in the chat. ARQs handled that better.
Okay.
And the other, really key for our discussion, was hallucination prevention. A lot of the errors made by chain of thought that ARQs avoided fell into that category, making things up or ignoring constraints.
That's exactly what we wanted to see. The structured approach directly leads to fewer hallucinations and better rule following.
What about efficiency? Does all this structure slow things down or use more resources?
The practical side. They looked at computational cost, basically measured by output tokens. It's a bit mixed, depends on the module.
So?
For the guideline proposer, ARQs were actually more efficient, used fewer tokens than chain of thought, while being more accurate.
Interesting.
But for the message generator and tool caller, ARQs tended to use slightly more tokens than COTI.
So, a potential trade-off. Slightly more computation in some parts, but you get better accuracy and reliability, especially preventing those bad hallucinations. That seems to be the case. It suggests you need to be smart about designing the ARQs. When they can really focus the model effectively, like in the guideline proposer, you might even save resources. In more complex generation tasks, the structure might add a little overhead, but the payoff is in quality and safety.
Seems like a worthwhile trade-off in many customer service scenarios, I'd imagine. Okay, this has been fascinating. Let's bring it back to you, our listener. Why does all this matter? What's the big takeaway here?
Well, if you've ever been frustrated by a chatbot giving you nonsense, ARQs represent a concrete step towards fixing that.
Yeah.
This research shows that actively guiding AI reasoning with structure, rather than just prompting it loosely, can make a real difference in reliability. It boosts trustworthiness for complex jobs like customer service.
It's that aha moment, isn't it? Maybe just letting the AI riff isn't always best. Sometimes structure is key.
And think about the impact. If this works at scale, it could genuinely transform customer service. Agents that are not just fast, but consistently accurate, compliant, that follow the rules.
That builds trust, both for customers and for businesses deploying the AI.
Right. So understanding ARQs gives you a peek at the cutting edge, how we're tackling fundamental AI safety and reliability problems in practical ways.
So, quick recap. Attentive reasoning queries, ARQs, are a structured way to guide LLM reasoning. They use targeted questions to improve instruction following and, crucially, cut down on hallucinations. The Parlant framework shows this works well in practice for customer service.
Nicely put. And that leads to a final thought for you to ponder. As AI gets woven deeper into everything we do, how will these structured reasoning methods like ARQs change how we interact with AI? How will they shape our trust? And could this idea guiding the AI's hallucinations towards the right answers using structure be applied elsewhere? Beyond customer service, what other complex areas need this kind of reliable, controlled AI reasoning?
Really interesting questions to think about. If you want to explore Parlant yourself, remember it's open source, check out parlant.io. That's parlant.io and the GitHub repo. As always, let us know your thoughts. Thanks for joining us for this deep dive.